Welcome to our Mech 450D pulp and paper term project on wood-based activated carbon presented by myself, Roman Gill, Robert McGlatchy, and Jordan Sheets. So what is it? Activated carbon derived from wood is utilized in surface water and wastewater filtration systems to eliminate organic contaminants, including larger molecules such as MIB and geosmin. It is manufactured from specific varieties of wood and sawdust, typically through either steam or phosphoric acid activation processes. There's also powdered wood-based activated carbon. The powder is generated through the high temperature treatment of premium wood charcoal in the presence of a gas, typically steam or carbon dioxide. It boasts a significant capacity for absorbing impurities, making it ideal for purification and separation applications. So, what are the benefits? It is a highly porous material. Activated carbon powder, renowned for its highly porous structure, boasts an exceptionally high surface area, presenting an extensive network of interstitial spaces and pores. This intricate structure provides an immense surface for the absorption of impurities, with a myriad of active sites available for chemical interactions. Its efficiency: the combination of activated carbon powder's high surface area and porous architecture renders it remarkably efficient as an absorbent. This efficiency stems from its ability to rapidly and effectively trap and retain impurities from various media, including liquids and gases. This vast surface area ensures a swift and thorough adsorption process, resulting in the efficient removal of contaminants, pollutants, and undesirable substances. It is versatile. Activated carbon powder stands out for its versatility, offering a customizable solution to meet the diverse requirements of numerous industries. Through precise control of production parameters such as temperature, activation time, and precursor material, properties of activated carbon powder can be tailored to suit specific applications. This versatility enables its utilization across a broad spectrum of industries, including water treatment, air purification, food and beverage processing, pharmaceuticals, and many more. Lastly, it is environmentally friendly. Wood-based activated carbon powder emerges as a sustainable and eco-friendly choice, reflecting its origin from renewable biomass sources. Derived primarily from wood or other plant-based materials, this form of activated carbon embodies environmental responsibility by utilizing natural resources responsibly. Furthermore, the manufacturing process typically employs eco-friendly methods, minimizing environmental impact while delivering a product that effectively addresses contamination challenges without causing harm to ecosystems or contributing to pollution. As a result, wood-based activated carbon powder represents a consensuous choice for applications where environmental sustainability is a priority.
So now I'm going to talk about the importance of wood-based activated carbon in terms of society and also in the context of individual companies. As we know, land and water use are some of the biggest issues we face as a society today and are only going to get more important over time. Wood-based activated carbon helps by being a renewable way to treat wastewater, purify drinking water, and even condition soil used in agriculture. In the context of an individual company, wood-based activated carbon creates some potential efficiency improvements for companies that deal with wastewater. For example, there's a peer-reviewed study that found that adding wood-based activated carbon to a membrane bioreactor that treated distillery effluent enhanced flux by about 23%, prolonged duration between filter cleaning, and also allowed for higher load rates. So these efficiency improvements would translate to dollar savings for companies, which gives them incentive to use this product. Now onto the estimated environmental impact. So as we've mentioned, it's renewably sourced. It's sourced from byproducts like wood dust and wood chips from sawmills. It's also biodegradable, which reduces the environmental impact of disposal. As I previously mentioned, there are some potential wastewater efficiency improvements for individual companies, and this would lead to basically less energy input. It also has a smaller carbon footprint compared to alternatives like coal-based activated carbon, which obviously involves mining coal, which is a much more energy-intensive activity. Wood-based activated carbon is also a more environmentally friendly replacement for synthetic polymer-based absorbents. These polymer-based absorbents would obviously not have the biodegradable aspect, making them worse for the environment.
So for tree to bioproduct, overall we have activated carbon materials are made through three required processes. The first is the pre-treatment process of the biomass raw materials. The second is activation, and the third is post-treatment. For the pre-treatment process, there's a lot of possible types of raw materials that you can input into this process, such as woods, tree barks, leaves, grasses, roots, and of course sawdust. The pre-treatment process is required to remove impurities and nutrients from the raw materials. The material is soaked in distilled water for about 12 hours, depending on the type of process and use, and then set out to dry. Here's the activation process. The activation process involves a chemical activation and a thermal activation. For the chemical activation process, it is really meant to chemically degrade and dehydrate the material. This is done firstly by heating the product at approximately 320 degrees for 5 hours. That temperature and time is variant depending on, once again, the usage. Then from there, it's exposed to a KOH solution and then again heated at 700 degrees Celsius for 2 hours. Once again, that temperature and time can be variant. From there, thermal activation. This is as simple as it is thermally heated to 900 degrees and can range from a couple hours to 24 hours, once again, depending on the type of process and use. In this picture, you can see a typical drying drum that is used for this type of process. And here's post-treatment process. The post-treatment process is its main goal is to get rid of any lasting impurities and balance the overall pH. You can do this by using distilled water or an acid or alkali solution to help achieve a balanced pH. And then from there, the product can be air dried or dried at a lowish, like 120 degrees Celsius drying temperature.
Moving on to the properties of the material. The properties of wood-based carbon includes sorption and desorption, allowing it to adsorb larger molecules. Suitable applications for this include decolorizing, such as beverages and pharmaceutical products, purification of edible oils, sweeteners, starches, etc., solvent recovery, and finally, vehicle evaporated loss control devices, which are used to prevent the gasoline fumes from leaking into the atmosphere, which are found in cars' fuel systems. Decolorizing applications. The following parameters, methylene blue adsorption and molasses index, are used to measure the performance of products. Methylene blue adsorption indicates capacity for absorption of medium-sized molecules, including dyes, and is higher for carbons which have a majority of mesopores, typically 2 to 5 nanometers in diameter. Mesopores are nanoporous materials containing pores of the stated diameter above. Molasses, a viscous substance, is used to indicate the capability to adsorb large molecules due to the solution of adsorption of molasses, where it is also strongly dependent on the mesopore structure.
The economic review for activated carbon is looking promising for the future, just because of the way our world is actively looking for more sustainable options. The instant costs that you automatically can see associated with this process are fixed costs and variable costs. For fixed costs, we have the upfront machine purchase costs, routine maintenance to keep these systems running, and your operator costs for somebody to always be running this. Your variable cost is your power cost, just kilowatt hours. That can change depending on the rate and how much use. Your raw material cost could change depending on if you're buying your raw material from somebody, but ideally this would be your waste from another process in your mill. So this would really be no cost, hopefully. Your consumable cost is just your, let's say, chemicals that are being used during this process that are going to not be usable again. The only really negative with this that would probably deter mills from using this would be your upfront cost. But if you're using your waste as your raw material, this seems like a no-brainer over time. And here are our references. Thank you guys for listening.